My name is Steve Flanders, and I'm a Senior Solutions Architect on the Vcenter Log Insight product team at VMware. And I'd like to talk to you today about query building in Vcenter Log Insight. But first, a quick introduction of the product. Vcenter Log Insight is capable of managing all of the unstructured data in your data center. It complements other cloud management tools, such as vCenter Operations Manager, which handles the structured data within your data center. Vcenter Log Insight allows you to aggregate all of the events within your data center, specifically the syslog messages, the logs, from both VMware, infrastructure, application, and operating systems. And then it gives you a powerful way through an HTML5 interface to query through your events, create dashboards, charts, as well as alerts and extracted fields. Powerful ways of adding structure to your unstructured events. And with that, I'd like to go ahead and show you a performance deep dive of Log Insight, something that was given at one of the VMworld sessions at VMworld 2013 this year. So basically, the goal here is to talk about some of the performance considerations when using vCenter Log Insight and some of the potential performance issues that you may run into. This would include things such as dropping events or having slow loading dashboards. Now, there are reasons why this might occur, but of course you want the system to run perfectly, and if you follow the defined best practices and configuration maximums, you can ensure that that happens. So let's talk a little bit about the system architecture and understand how Log Insight works. There are two pipelines to be considered. The first is the Ingestion Pipeline, which can handle both TCP and UDP traffic, as well as SSL log messages via TCP. The Ingestion Pipeline happens over syslog, and once messages are received, they go through a multi-stage pipeline where they are processed. The goal is to create both an index of the full or complete text keywords in the actual events themselves, as well as the compressed log messages. Now, this multi-stage pipeline is threaded and is able to effectively use all the resources available to it, CPU, memory, and storage. Now, for each of these threaded pools, there's a buffer that's in place. So if a threaded pool is slow, perhaps you have contention in the virtual machine, or it's oversized for the ingestion rate that's coming in, you can go ahead and use the buffer space that's available. It's a fixed buffer size based on the available memory that you have on the Log Insight virtual appliance. Now, these buffers or caches allow for back pressure to happen throughout the different threaded pools. And as one buffer cache fills up, it can leverage other previous buffer caches available to it until it gets back to the syslog pipeline. If all the pipelines become full, if all the buffer cache is in use, then at some point we start dropping messages from vCenter Log Insight. Now, you want to be able to handle this situation and ensure that you're not dropping messages in your system. We'll talk about some of those considerations momentarily. The other pipeline to consider is the query side of the house. So once the messages have been ingested, we have the index and the raw text messages compressed and available, we can actually query over them. So you get near real-time search. All search is done through the web server through its HTML5 interface, and it's basically clients requesting information or alerts that run on a predefined schedule. So again, in terms of querying, we have a threaded pool model, so we can have concurrency. We're able to leverage all the CPU and memory resources available to us. And as each process finishes, if we have a queue or pending transactions that need to happen, we can use one of the available threads. With that, let's dive a little bit deeper. Looking at the ingestion pipeline, it's mentioned that it's a multi-stage threaded pipeline with buffers and caches in place. But in terms of resources, what do you need to consider? The most important consideration is actually CPU resources. And that's because as events are coming into the system, we have to go ahead and create the full keyword index, which makes it much faster to query over the data, but that requires some CPU computation time. We also need to compress those messages so they take less space on disk so we can store more of them and keep a longer retention. So CPU is probably the most important consideration. Memory can help, but there's already a fixed size buffer or cache, so it can only help a certain amount. Disk IOs are important because we're going to be writing to disk, but they're all sequential in nature, so it's more of an effective IOP type model than anything else. And as for network, in terms of bandwidth, syslog messages are relatively small, and even if you have a lot of them coming into the system, they won't saturate your network. But network is still very important. You want to make sure that you have a reliable connection. You want to make sure that each of your client systems are able to send to a Log Insight instance and that those messages are actually received. If you're over an unreliable connection, perhaps over a WAN, the network connectivity issues can result in messages not being received. You can use things such as TCP to ensure that the messages actually make it to the Log Insight instance. So in summary here, in the ingestion pipeline, CPU computation time, if you're noticing a high CPU utilization, it's time to add more cores. But there's a fixed number of cores that Log Insight will generally use for the ingestion pipeline, and that's 6 today. It's not that Log Insight can't handle more, it's that we want to save some of the computational time for querying, because in addition to ingestion, you actually want to be able to get the results back from your system as well. Memory can help for the incoming spikes in your environment, but it shouldn't be relied on for long periods of contention. You want to fix those performance issues in your environment and ensure that the resources that you allocated to Log Insight are available. IOPS is important from an effective IOPS standpoint, so the sequential writes can be written to disk, but other than that, network is typically not an issue for the ingestion pipeline, and bandwidth for network, it only really matters about the reliability, not about the bandwidth. Next, let's switch over to the query engine. Here, we have to worry about high performance querying so that we can handle the load of multiple systems, of multiple people using the system at the same time. So we made it high performance. It can leverage multiple cores. It can leverage all the CPU, all the memory available to it, and all the IOPS. And we also made sure that we put some admission control in place so no thrashing could happen, where we'd actually be leveraging more resources than we expected, or having one query take over the system. But if you actually look at the resource footprint for queries, it's significantly different. Now almost every aspect is important. CPU is important in order to actually process the query that's coming in, like applying regular expressions. Memory is important because we can actually pull off of the disk and into memory to actually handle the processing to return the results to you more quickly. Disk or network, disk IOPS is also important because we have to read that data off of disk, and the larger the time range that we're querying over, the more events we have to pull off the disk and go find. And network is still just more important from a reliability standpoint to ensure that you're getting the results on your web server. Now, I'd like to talk to you about some specific performance considerations when it comes to querying and Log Insight. The first we have here is actually the time range that you specify. So every query in Log Insight would happen based on a fixed time range that you specify. Log Insight defaults to the latest 5 minutes of data. That's because we're trying to refine the number of results that are returned. If you know that an issue happened yesterday between 10 and noon, then you should specify a custom time range looking at just for the events yesterday between 10 and noon, because that reduces the amount of events that have to be sought on the disk, returned back, and then CPU time spent on applying regular expressions or performing your actual query to get your results back. So limiting the scope of your time range is extremely important and something to take into consideration. Next would be keywords versus regular expressions. So when you construct a query in Log Insight, it happens based on complete or full text keywords. As mentioned earlier in the ingestion pipeline, when messages come into the system, we build an index. And that index is based on complete or full text keywords, making it much faster to search for results. Now, when you're searching for a complete or full word keyword, you do not have to actually look at the raw compressed messages. You can just look at the predefined index that we built. When you have regular expressions, the index is not sufficient. You also need the raw compressed logs. You need to look at both, and you have to apply the regular expression to the events in order to return them back to the user. This can be extremely costly depending on the regular expression that's being implemented. So there's actually a couple examples here. You can see a couple images, one where it says text matches error or info in regular expression format. You see the parentheses in the pipe. And the alternative is text contains error, comma, info, which in Log Insight would be 2 keyword matches, error or info. The second query is actually much faster, as the regular expression does not need to be applied, the raw compressed logs are not necessary, and the index can be used to serve the request. In terms of performance implications, regular expressions versus keywords can have up to a 10 times performance difference. So it's very important to limit and only use regular expressions when you really need them. If you must use regular expressions, the more keywords you can supply, the better. Log Insight is smart enough to perform the keyword queries first to get a subset of the results returned to you, and then it will apply the regular expressions to what's left, making the regular expression less expensive. Field extraction is something that's also possible. It's a way of adding structure to your unstructured events in Log Insight. And once you've actually created a field, you can use it in a query. You can use it as part of an aggregation function. It's a way of getting additional insight or further refining the results that are returned to the user. Now, field extractions are based on regular expressions, and it's important that while defining your regular expression, you have keywords or context that is sufficient without a regular expression. So a field is made up of 3 different attributes: the value, the item that you're looking for within the event message itself, the pre-context, what happens before it, and the post-context, what happens after it. Now, the more keywords you can supply and the less regular expressions you can use, the more optimized the query. And we have 2 examples for you here. You can see that we have an event, and we're trying to extract the number 128 from the event that's listed here. Now, by default, what was selected as the pre-context was VM, and what was selected as the post-context was VPXA. 1 keyword at the beginning, 1 keyword at the end. But you can notice that there are several other keywords that could be added to this query. For example, set internal stats for VM. We now have 1, 2, 3, 4, 5 keywords at the beginning and 1 at the end, 6 keywords. The second query is way more optimized. There will be less regular expressions that need to be applied to less returned results, making the query significantly faster. Now, at the end of the day, there are some regular expressions that are going to take a long time on any system. They're just not optimized, as you can see an example here. And there are 2 primary reasons why these types of regular expressions are run. One, because the user just didn't know that there was a better way to do it, and the second is because it was maliciously done, trying to bring down the system. So it's important that an administrator can actually cancel these queries and prevent them from taking away necessary resources from Log Insight. And that's possible from the administration page of Log Insight. All queries that are running or pending to be running in the system are listed, they're viewable, and you can see how long they have been running or how long they have been waiting. And an administrator has the option of actually canceling any of the queries. So if you notice a runaway query or something that's consuming a large amount of resources on your Log Insight virtual appliance, you can go ahead and cancel that query and notify the user. So in recap of performance here, it's important to note that CPUs will help with both the ingestion pipeline as well as query processing. The more you add, the more is available to the thread pools. And we have a sizing guide that specifies small, medium, and large configurations. So as you deploy the virtual appliance, you can see how many resources are necessary. Memory helps, especially for spikes or unexpected increases in events in your system, as this increases the buffering and caching available to Log Insight to use. Faster I/O also helps. You need to be able to read the information off the disk quickly in order to make it available for CPU processing to return your query to the user. And network bandwidth is typically not the concern. But it's very important that everything that I discussed here, it heavily depends on the actual query that's being written. Every query is slightly different, every query will have certain needs, but these are some of the key characteristics that you should keep in consideration when you're running Vcenter Log Insight. So I encourage you to go ahead and download Vcenter Log Insight from the VMware product page, available at vmware.com/go/try-VMware. Now, we just released a new 1.5 beta, publicly available, free for download as well. And you can find more information about that on our community page at loginsight.vmware.com. Thank you.